Hi everyone, welcome back to my channel. Today let's understand a very important microservices interview question. What is Saga pattern in microservices? Before we go into the detailed flow, let me first explain what Saga pattern actually means in simple terms. In a microservices architecture, a single business operation can involve multiple microservices. For example, when we place an order, the request go through order service, payment service, inventory service and notification service. Now each of these services may have its own database and its own local transaction. So we can't treat the entire operation as one single database transaction and simply roll everything back if something goes wrong. This is where the Saga pattern helps. Let's come to the points in image. First point is Saga pattern manages distributed transactions across multiple microservices. Means in microservices, one business operation can involve multiple services. Saga helps coordinate these operations even though each service has its own database. Next point is it breaks big business transactions into sequence of local transactions. Means instead of treating the entire operation as one database transaction, each service completes its own small transaction. Next, if any step fails, Saga executes compensating transactions to undo the previously completed steps. Means now imagine that order creation succeeds and payment succeeds but inventory reservation fails. Here we can't simply roll back everything using traditional database rollback because these are separate services and potentially separate databases. So Saga uses compensating transaction to undo the effects of the transactions that already succeeded. For example, inventory fails, refund payment and cancel the order. This is the most important concept in Saga. Next point is Saga doesn't provide immediate consistency but ensures eventually consistency. Means Saga doesn't provide immediate consistency across all microservices. There may be a short period where one service has successfully updated its data, while another service has not completed its operation yet. After the successful steps and compensating transaction completes, the system eventually reaches a consistent state. Next, why Saga pattern? Why do we actually need the Saga pattern in microservices? In a microservices architecture, a single business transaction can involve multiple services and multiple databases. For example, when we place an order, the request may go through order service, payment service, and inventory service. Each service may have its own database and performs its own local transaction. So, if the order service and payment service are successful but the inventory fails, we can't simply use traditional rollback using transactional across all services because they are separate database transactions and potentially separate databases. This is where Saga pattern helps. Saga coordinates these local transactions and if something fails, it uses compensating transactions to undo the effects of the previously completed steps. Next, let's take the example as shown in the image. First, the order service creates the order and saves it in its own database. This local transaction is successful. Next, the payment service processes the payment. Since the payment is successful, its local transaction is also completed. Next, now the inventory service tries to reserve the product, but let's assume the product is unavailable. So this transaction fails and notification service skipped because the inventory reservation failed. So we don't proceed with the notification step. Now Saga needs to compensate for the transactions that were already completed. Next, in compensate, since the payment was already successful, the payment service performs a refund. Then the order service cancels the order. So the complete flow is order is succeed, payment is succeed, but inventory fails. Then refund the payment and cancels the order. Next, now let's understand the Saga pattern with a simple code example. Here first the order service creates the order and we get the order ID. Then we process the payment. If payment is successful, we move to the next step, inventory service. The inventory service tries to reserve the inventory. After that, we send an order confirmation through the notification service. Now imagine that one of the steps fails. Instead of simply roll back everything using database transactions, we execute compensating actions. For example, if inventory fails after payment was successful, we can refund the payment and cancel the order. So this code is only a simplified example to demonstrate the core idea of Saga. Local transactions plus compensating actions when something fails. Next is there are two types of Saga. First is choreography. It is event based. In choreography, services communicate by publishing and listening to events. In choreography, there is no central coordinator. For example, when the order service creates an order, it can publish an order created event. Next, the payment service listens to that event, then processes the payment and publishes another event. The next service listens and continues the flow. So the services coordinate with each other through events. This approach commonly implemented using messaging systems such as Kafka or RabbitMQ. Next, the second type is orchestration, which is command based. Here we have a central component called Saga Orchestrator, which controls the entire flow. It sends a commands to services and waits responses. Means the orchestrator tells the order service to create the order, then tells the payment service to process the payment, and then tells the inventory service to reserve the inventory. The services perform their local transactions and send their response back to the orchestrator. The main advantage is easier to monitor and manage complex flows. Next is interview ready answer. If the interviewer asks what is Saga pattern, you can answer like this. Saga pattern is a way to handle distributed transactions in microservices. Instead of using a single database transaction, it breaks the business transaction into a series of local transactions. Each service performs its own transaction. If all steps succeed, the process completes successfully. If any step fails, Saga triggers compensating transactions to undo the previously completed steps. This way, it ensures eventual consistency across all services. Saga pattern has two types: choreography and orchestration. Choreography is event based and orchestration is command based. That's all about the Saga pattern. If you found this video is helpful, please subscribe my YouTube channel and follow me on Instagram for more Java full stack real time interview questions. Thank you.